Well, the tank of volume is given with the temperature and pressure and contains saturated air. So let's list the information that is given to us first. As the rigid tank, volume is 10 meter cube. Temperature, which is the dry bulb temperature. And the total pressure is 101 kPa, standard atmospheric pressure. And also is given that saturated air, which means what? The relative humidity is 100%. And we're supposed to find specific humidity. So let's list a few things we want to find. Let's say we want to find specific humidity, pressure of water vapor, pressure of dry air, mass of dry air, mass of water vapor, and specific volume. So all these quantities we have already, all these properties you already know what they are. Let's see how we find these quantities manually and verify using appropriate test calc. And when you find them manually, let's do both ways, using formulas and using the psychrometric chart. Okay, first thing first. The total pressure is given to us, so we know total pressure is PV plus PA. And what is PV? PV is phi times PV max. And PV max is also called PG, the G point in your PC model, or P set at the given temperature. In this case, phi is given to us as 1 or 100%, and P set at 25 degrees Celsius. We can quickly go and check that out. So we go to property tables, and to find the saturation pressure from a given temperature, we go to the temperature saturation table. At 25 it is 3.169 or 3.2 kPa. So we found PV. So one thing is done, and therefore PA we can find from 101 is the total pressure minus 3.2 kPa. So therefore PA can be found 101 minus 3.2, which is 97.8 kPa. So we already found two different quantities. Let's go ahead and calculate omega. And recall that omega, which is the humidity ratio or specific humidity, is the definition is mass of vapor over mass of air, which is given by the following formula. So if you know the vapor pressure and total pressure, we can obtain omega from this formula. We can easily calculate that. Therefore, PV we just showed is 3.2, 10 minus 3.2, and that turns out to be approximately 0.02, and the unit will be what? Kg of vapor, kg of dry air, right? Or most of the time, the vapor is so small, it is multiplied by 1000, and it's written gram of vapor per kg of dry air. That's sometimes the unit used in the psychrometric chart. So we calculated omega, we calculated PA and PV. Let's go and calculate the mass of dry air. So to calculate mass of dry air, we can use PV equals pressure of air, volume, MARAT. So when you use this formula, we can obtain the mass of dry air as pressure of dry air times volume by RA times temperature. substituting the values, which are, we already figured out the pressure of dry air in the previous section for 97 point, this is 9, oops, 97.8, 10 meter cube, 0.287 is RA, and temperature is 25 degrees Celsius, which is 273 plus 25 Kelvin, and that turns out to be about 11.44 kg. And now that we know omega, omega is 0.02 and ma, therefore mass of vapor is simply omega times mass of air, so it's 0.02 times 11.44, and that turns out to be approximately 0.23 kg. So the tank is holding 11.44 kg of dry air and 0.23 kg of water vapor, and the air is completely saturated at that point. So the specific volume is quite simple because we know the volume of the tank. Recall that specific volume is defined as volume per unit mass of dry air, meter cube per kg of dry air. Volume is known, given in this problem, 10 meter cube, and mass of dry air we just calculated to be 11.44, and that gives us specific volume to be about 0.874 meter cube per kg of dry air. So let's see different ways of solving the problem. So again, we would like to find out all these variables. We would like to know what is omega, what is PV, PA, MV, MA, etc. using the psychrometric chart. So let's go and try to calculate these quantities using the psychrometric chart. So we will start property tables, and psychrometric chart is table F. We open the chart and let's see if we can locate the state. So as you recall, this is our temperature axis. This is our temperature axis here, dry bulb temperature. As you can see, it goes from -25 to +55 degrees Celsius. And these are our PV omega axis. I know it looks complicated, but let's see what is given in this problem. We know the temperature is 25, and we also know it's saturated. So remember the saturated line, phi equals 100% humidity. See, these are the humidity values, 90% line. This is the 100% line. And 25 degree, actually 25 is also written here. So this is exactly our state. So this is the state. So we located the state on 100% humidity line and dry bulb temperature. Now that we know the state, we can read off a lot of variables here. First is, this is the relative humidity, the specific humidity, I'm sorry, given in moisture per kg, gram per kg, gram of water vapor. So look, it's 20 here, 22 here, so about 20 I would say the value we get is about, if you have to just 20.2. So we find specific, so we find this state to be, from here we can pick up the value to be approximately what we got, 0.02. The vapor pressure is given in millimeter of mercury. Of course, we can convert that if you want into kPa using a converter. And notice the specific volume lines are these lines, and there's a line passing here, there's another line passing here, that value is 0.88 here, 0.86 here, so this must be 0.87. So pretty close to 0.87 I'll say, so I'll just pick up specific volume to be 0.87. So we found omega from here, specific volume from here, from this line of constant specific volume, and knowing the vapor pressure, one can calculate the dry air pressure. Let me clear this screen and go back here, and you will see the specific volume is close to what we got manually.